Hello everybody, welcome to our very first PCB workshop. My name is Kwong Lee and I will be your course instructor for today's workshop as well as your next workshop. And in the chat today we also have Nolan Davenport, who is also the second instructor for this workshop. So I'd like to thank you all first and foremost for coming out. This is my first time doing a workshop, so it really means a lot that you guys took time out of your day to come and attend this workshop. So Nolan, if you're in the chat right now, could you please drop a hello and let everyone else know you're here as well? So before we begin, I would like for you guys to sign in first and foremost. So I will give you guys a few minutes to handle that. Okay, so it seems like we have a good majority of you guys who have signed in, so we can continue with the workshop now. So, in essence, what is a PCB, right? So all we know is they're like these green little looking plastic boards, right? Metal boards, if you will, as well. So essentially what they do is they're boards that allow you to connect components to each other without having to use wires, in a sense. What we use instead to connect components to one another is we use these things known as copper traces. And these copper traces are what electrically connect your components between each other. So if you look here at these images, you'll see these little lines, and those are what our copper traces are. So these boards can have multiple layers, and most people, when they're working with PCBs, they like to stick with around 4 boards. Doing so allows you to dedicate one layer to a specific use. So in our case, with our second workshop, because this is a 2-part course, in our second workshop, you'll notice that we dedicate one layer to completely grounding. And so that's one of the benefits that you get with multi-layer PCB boards. So why do we use PCBs, right? So PCBs, they allow you to take this ginormous circuit and they allow you to put it onto this small little compact board, and it makes things really easy to repair and to diagnose. And on top of that, if you ever decide to take it anywhere, it's immune to movement. So if you accidentally shake it a little bit, right, you're not going to have components falling out on you because they're soldered to the board. So here, I just wanted to give you guys a little example or a show, I guess. So before PCBs became really common in the 1960s, we had things that looked like this. So on the left-hand side, you'll see a 1948 Motorola 7-inch TV. And so you can see all the circuitry that goes into this, like, right? Do you see how much of a pain that would be to diagnose or to have to try and take apart just to look for something else? Like, it's really hard to modify and really hard to repair. So if you look on the right, this is a modern day Samsung TV, and this is for a 32-inch TV, mind you. And this is the PCB that we have going for it. So with this, you can test and you can modify and you can see you can't really modify. Once you put it on the board, it's there. But it's really easy to diagnose what's wrong with it in this case. So for today's presentation, we will be using KiCad as well as the rest of our workshops. The reason why we decided to go with KiCad is because it's open source and it's free, and who doesn't like free things? It also allows for simulations. So for those of you who are familiar with other software like PSpice, you'll know that there's various simulations you can do on circuitry. And so KiCad also allows that type of analysis, except it is not to the same extent. And lastly, there's a 3D model viewer. So if you look on the right, this is something you should expect to see when we go ahead and model our PCB after it's completely finished. And this was actually a huge reason why we decided to go with KiCad, because with the other software, it did not have that. And since we're in the middle of a pandemic and we can't physically go and build and solder our own board, this is a pretty good alternative. So for those of you who have KiCad, we can go ahead right now and open up KiCad. So to do this, we're just going to open it from here, and you're going to be greeted by this screen here. So I'm going to give it a sec for you guys to open up KiCad. So with here, I know this looks a little daunting and it just looks a little weird because for those of you who this may be your first time doing it, it's just something you're not familiar with. So what we're going to go ahead and do is we're going to go to File in the top left corner. We're going to press New, and then we're going to go to Project. So from here, you can navigate to the directory that you would like to keep it in. So I'm going to do the same. So what I like to do is I like to make a folder for every single project that I'm working on because I like to just keep it nice and organized. So we can title this Workshop 1 PCB, and then we can press Save, and then we also need to give the file a name as well. So once you have the file name created, you can go ahead and hit Save. And then from this point, you'll notice that you get this schematic, this .schematic file, and this .pcb file. So what we're going to do is you don't have to worry about this PCB file just yet. We can go ahead and just worry about this schematic file. So if you double click on this, you'll be greeted with another KiCad window, and this is what we're primarily going to be working on today. So to your right hand, you're going to have this menu bar, and this has all the tools that we're going to need for today's workshop. So before we do anything, I'd like to give you guys a moment to catch up, as well as I'd like to make a little statement here. So with this workshop and the next workshop, this is meant to be an introductory course. So we're going to be covering really basic things, and I'm aware that some of you may have prior experience with doing things like this. So I know this may not be all that interesting to you guys, but so I recommend that you guys go to our more advanced workshop, which will actually be hosted by Nolan, who is in the chat right now talking to you guys. And so that will be held after spring break, and it'll be more advanced, and I'm sure you guys will enjoy that one as well. So to start, the circuit that we're going to be working with today is this circuit right here. So this is a 555 timer, and all it does is pulse an LED, right? So this is a simple little circuit, and I think it does what we need to showcase pretty well. So the first thing we're going to do is we're going to make sure we're at this window, and to our right hand, we're going to look for this op amp symbol, this icon, right? And you notice that if you hover over it, it'll tell you play symbol, and that's what we're looking for today. So when you do that and you go back to your when you go back to this window, you're going to notice this little pencil. And so if you click, it'll load this library. And this is normal. This will happen when you open up a new project, and it'll take a sec to load. And so you just need to give it a little bit. So once that happens and it's done loading, this other window will show up. And so you can expand this window by just dragging the little corner with the dots. And these are the libraries for the components that KiCad comes with pre-installed. And this is a pretty vast library, and it'll usually have everything that you need, but if not, you can create your own symbols actually. And Nolan will actually be showcasing that in his workshop. So if you really want to know how to do that, then you guys should be sure to attend that one. So from here, you'll notice these little plus signs, and doing that will expand the library and allow you to choose components. And in this window off to the right, this window will also give you a picture of what that component is. So this is what this would look like. So what we're looking for today is an LM555 timer. So we can do that by using the search bar, because let's be honest, no one wants to go and have to expand every single one and look for it. So if we just type in LM555, you'll be greeted by these. And so you'll notice all these terminologies here. And so if you see SOIC and PDIP, those stand for, these are different types of mounting mechanisms actually. So one of them, this SOIC, stands for surface mount, and this one stands for pin through hole. And these are just different ways to mount components to the board. So the one we're going to go with today is this LM555 with the PDIP, right? So if we do that, you'll notice that it's faded when we double click it. And so once we click on this window, it'll place. And to zoom in, you can use your mouse scroll bar, or you can use these two icons up here. But I find it much easier to use the scroll wheel. So from this point, we need to keep adding the rest of our components. Now we can keep on pressing this button right here, this place symbol icon, or we can go ahead and press a shortcut key. And the shortcut key to place symbols is to just press A. So if you press A, you'll notice that it'll open up this same symbol library that we were just working with. So if we go ahead and type in resistor, we're going to need 3 of these. So we can go ahead to R_US, and that gives us the resistor that we're used to working with in class. So that's why I chose this one right here. We're going to add that to our editor, and there you go. You'll notice that it gets placed just like our 555 timer. So you'll notice that when you work with a lot of components, it can become a pain to have to constantly press this button over and over and over, right? So what we can do is we can select this mouse icon, and if we highlight like this, you'll notice that we can move the component. If we do this to multiple components, we can move it. But also, if we highlight and then do Control C, it'll place the component back to where it originally was. But if we do Control V, you'll have another one. It duplicates it, right? And you can also duplicate multiple. So that saves you a lot of time in that instance. So we're gonna add one more resistor here because we need a total of 3. Then we need to go ahead and add our capacitor. Which is right here. We can go ahead and add that over here. And lastly, we need to add our LED. So we can type in LED in the search bar. And another shortcut is if you press R, it'll rotate your component. So we can go ahead and do that. And I want to orient it downwards like this. And then you'll notice that right now, my cursor still has the place symbol icon. So if I press escape, it'll automatically go back to this mouse icon. And I know there's a lot of shortcuts, but shortcuts do what they're meant to do. You know, they make it really easy for you to switch between stuff, and it really helps with workflow. So what we're gonna do now is we're gonna edit what are known as field references. So if I zoom in here, you'll notice these question marks next to all of these components. And so we can edit those by double clicking on it, and it'll automatically highlight the question mark portion of that text. You can type in R1, and then we continue to do that for the other resistors. So now what we can do is we can go ahead and edit the resistance values. So for our first resistor, we're going to do 470k ohms. And you don't have to write ohms or anything. You can just put the value as well as the units. Oh, I'm sorry. 470. Then we can do 1000, then 1000. Here, this will be 1 microfarad. So to denote microfarad, we're going to go ahead and put a U for micro and then F. And so this gives us the field references for our components today that we're going to be working with. So what's left? We need to wire everything, correct? So to wire, you're going to go over to your menu bar and you're going to see this green stick looking thing. Well, what this is if you hover it, it's your place wire. So you notice these little circles on the ends of every component. These are the terminals to which you're going to wire everything. So we can go ahead and wire terminal 2 to terminal 7. I want to move this component, this R1, I'm sorry. So to move that, we're going to highlight it and we're going to bring it over here. Then we're going to rotate it. So if we rotate it, we'll orient it like this. And there you go. What's left now is to wire R3 and to pin 3. So there's another way to do this with the shortcut, with the W key. So if I press W here, it'll automatically place the wire and then I can put it here. But something to note for those of you who have worked in things like PSpice, if you press W, what it'll do is it'll just highlight the tool. But here in KiCad, if you press W, it'll automatically place the wire at the position of your cursor. And so for those of you who are making that transition, I know it can be really annoying. So if you want to avoid that, you can do Shift W. And doing that, if I press Shift W and you look at my menu bar, if I do Shift W, it'll go ahead and highlight it, but it doesn't place a wire. So that's one thing. Another thing I'd like to point out here is you'll notice that I connected R3 to pin 3 and R2 to pin 7. But the question here is you'll notice these wires intersect, right? Now you might be wondering, does this mean that they're electrically connected? And the answer is no. So they're not actually connected. Even though they cross, they're not connected. You can tell they're connected if a circle appears, and this circle is known as a junction. So to showcase that, if I go over here and I place a wire and I draw it right on this wire right here, you'll notice the circle appears, and that's the junction I was talking about. And only if you have this does it mean that it is connected. So I'm gonna go ahead and delete this because I don't want it to be connected like that. And then I want to reorientate this wire so it looks like this. I want to delete this one. So here we're gonna continue wiring all of our components together. So I'm gonna wire this third pin to our third resistor, and then I'm gonna wire the other terminal of this resistor to our diode. Something else I'd like to point out is if you want to move a component, right, and I want to move this LED, you'll notice that when I go like this, the wire stays fixed. And that can be a pain sometimes because it's just really annoying having to delete the wire and then redraw the wire. So one way to fix this is you can highlight the component. You can highlight the component and you can press G. If you press G, it'll take that wire and then it'll allow you to fix the distance. It'll allow you to move this while also changing the length of the wire. And so that's a really useful shortcut to know. Here, we're gonna wire R1 to our 6th pin of our timer, and then here you go, we're here. So what's left from this point? So from this point, we have to add our power. So how are we gonna do that? So if we go over here, we're not actually gonna use the symbol one. Instead, we're gonna go right under it to what's known as a power port. So this power port is you're gonna open it the same way you did your symbol library. So you're just gonna press, and it'll open up this. And you'll notice that there's significantly less libraries for this one because it's just power. And here are all the different flags. So these are the voltages, and there's different flags. There's ground, there's everything else you might need. And there's also the filter search. So for our circuit, we want to use 9 volts, but instead of using this flag here, what I want to do is I actually want to use something else. So we're going to go back to our symbol library. We're going to go ahead and open it. And we're going to type in screw terminal. And what we're looking for is this screw terminal with a 0, 1 by 2. And we're going to go ahead and put it here, and we're going to rotate it. Just like that. We're going to put it down. So here, we're going to do the same thing that we did with all our other components. We're going to edit this field reference. Now, what about this field reference? Well, since we don't have that many components, and we know what this is by sight, we don't need to know that it's a screw terminal, right? We already know that. So we can go ahead and hit this visible check mark, and it'll remove it. So if you look like that, look, it's now gone. Now, so to go back to our previous wiring, you'll notice that we still have some things that aren't connected, right? So this resistor right here needs to connect to this, and then this will also need to go to ground. But you can tell that if I start drawing wires, right? When you're working with more complex circuits, you can start to see how complicated this can all get and how annoying it can be to have to track all the wires and to trace everything, right? So what we can do instead is we can use something else to connect our components together. And this does not actually require the use of wires. Would you believe that? So we're gonna go over here, and we're gonna press this global flag icon. What this does is if we press on it, here you'll have where the text of the flag will be. You can change the orientation of the text here. You can mess with the style of it, so we can bold it, bold italicize, whatever we want. And then here we can change the shape of it. And here you can also change the text size. So what we want to do is we just want to type in 1, and that'll be the name of the global flag. So if I go ahead, you'll see that now I have a global flag with the letter 1, but it's not placed yet, which is why it's still faded. So if I press R and rotate it like this, and then I place it on this resistor, then you'll see that the flag sticks to it. Now, if I go ahead and do the same thing over here, I have a flag over here now. Now, what does this mean? It means that here, R2 and pin 7 of this timer are connected to each other. But the nice thing is that we're not using it with a wire, right? So when you're working with those bigger circuits, you don't have to deal with a ton of wires all the time. But that being said, you have to be careful, because if I were to delete all these wires and just put global flags everywhere, it'd be no different than me just drawing wires everywhere, right? So the key is just to balance your use of wires and your global flags, and and if you do that correctly, then your schematic can be a whole lot easier to read. And this will become a lot more useful in our advanced workshop, and you guys will see that being used there as well. So to keep going, we want to put a global flag here on the end of resistor R1, and we're going to attach that like that. And you can see now that R1 is connected to pin 7, R2 is also connected to pin 7. So we want to continue wiring, we want to go over here to pin 4 of our timer, and we want to connect it to pin 8, right? But you'll notice that no matter how I try and move this wire, it'll let me go horizontally and then vertically. But then the second I try to go horizontally back to this wire, it connects pin 5, pin 2, and pin 8 all together. And that's not what we want at all. So what we're going to do instead is we're going to drag it out like this to the left. We're going to press once. And what that does is that fixes the wire in place. So by fixing the wire in place, it now sets this length right here and only allows us to adjust the rest of it like this. So we can go ahead and place it now on pin 8. And you'll notice that it did not connect pins 5 and 2 together, which is exactly what we wanted. Now, when we're working with a lot of components, things can start to get a little confusing, right? So with this terminal over here, pin 1 and pin 2 do not actually have designations for their use. So one can be used for power, the other can be used for ground. It doesn't matter. So if I wanted to use 2 for ground and 1 for power, then that'd be fine too. But for us to keep track of what we're doing, we need to label it somehow, right? So we can use this place text icon over here. We can use this tool, and this tool is strictly just for our reference. It will not mess with our schematic in any way. So if I go ahead and press down and I type in 9 volts, here, I want to change the text size to 3 millimeters, and then I can bold it. And when I press OK, you'll see that I have that. And so if I just want to move this, I can put it right here. And you'll notice that this J1 gets in the way, and if you try to highlight that J1, it won't move. Like, it won't move, right? So what you can do in that case is when you're working with things like this, you hover over the text and you press M on your keyboard, and when you press M, you'll notice that you'll be able to move it, and there's also this blue line that shows up. And this blue line is just for you to be able to keep track of what these references go to. So we're going to move this way out here because we don't need it. We're going to put the 9 volts back here. We're going to continue using our text tool. We're going to type in a plus to denote our power, just like this, and then a negative sign to denote our ground. And so this is the current state of the circuit, and I'll give you guys just a second to catch up. Okay, so now we need to power our timer as well as providing electricity wherever else it needs to go. So we can go ahead and connect this right here, go like this to right there. And we want it to go right here so that pins 8 and pin 4 are connected to VCC. On top of that, we need to go here, right? But what you can tell is that it already starts to look a little ugly and a little messy, right? So if you couldn't tell where I was going with this, we're gonna use our power flags, because yay, we like flags. So what we're gonna do is we're gonna delete the wires that I just created. And instead, what we can do is we're gonna open up our power port, which is this icon right here, or we can press the letter P, and the letter P will provide the shortcut to opening that library again. And so we're gonna expand this power library, and then if we go down here, we're looking for 9 volts, and doing this places what's known as a power flag. And so we can go ahead and just put this here, here, as well as here. And so all that's left to do from this point is to connect them. And so what does this mean? It means they're all connected to our power source. And look at all the wires it saved us, right? And once again, I know it doesn't seem all too useful with this circuit, but when you're working with larger circuits, it's gonna help a ton. Just trust me on that. And so one more thing we have to do here is we have to put our ground. So to put our ground, we're gonna once again open up we're gonna use our power port, and we're gonna look for ground. So if we keep scrolling past all these voltages, these power flags, we're gonna come across these different grounds. And these are just different names, like you'll see ground 1, ground 2, ground 3, but we just want to go with ground. If we do that, we can go ahead and put it here. And that'll put our ground right there. And then I could draw all the wires and connect them to ground again, or I could do what I did with the power flags, and I could just put ground on every little terminal that needs the ground. So we're going to go ahead with that alternative. So you'll notice that here, once you use a component, it'll show up right here in this recently used, so that helps a lot too with having to deal with duplicates. So if we double click on that again, it'll put ground here. We can put ground right here. Oops. And so what's left to go from here is to wire everything. So we're gonna wire that to ground, and wire this to ground. And then we're going to wire this to ground. And then we need to connect pin 2 here to this capacitor. From here, we also need to connect this to, actually, let's do this. So if we press on this, if we highlight this really quick and we press G, oops. Yeah, okay. It's being a little funky with me. I'm sorry here. I'm just trying to move it down, but it doesn't want to work with me apparently. So here you'll notice where we just have a bunch of components intersecting with each other, and it's being really annoying. If you right click right here, it'll allow you to clarify the selection. So you can, from here, it'll show you everything that's happening at that position. And so you can just select what you're trying to select on. So if I want to do this wire, I'm just going to press delete wire and go here. I'm going to press this wire. I'm going to press, here. And we're going to go delete wire. And we're going to go here. And then press this. Okay, and delete that wire. We can zoom out. Make sure this is here. I want to move this right around there. I want to move this ground. Let's do like that. Let's move it like this. Here to here, and then here to here. We need to connect this over here to our capacitor, and then we need to ground this portion of our timer. So we're going to go back to our power port, press ground, and we're just going to bring it out here, and then wire this to this. Now remember, even though these intersect, there's no junction here like there is here and here. So these two are not electrically connected to each other. Now, at this point, our circuit is built, correct? But remember that we're putting this on a PCB. So we don't actually know anything about the sizes or the dimensions of the components that we're putting onto this board. So to deal with that, we have to work with something called footprints. And footprints are what allow you to specify the dimensions of the components you're working with. Because if you think about it like this, if you go to put a resistor on a PCB board, right, there's many different types of resistors in the way they're shaped. So we have to define those, and that's what we use the footprints for. So to edit our footprints, what we're going to do is we're going to go hover over the component that we need to, and we're going to press F on it. So if you press F on it, you'll notice this text box appears, and it says Edit Footprint Field, and you'll see this text, and then you'll see this Select button. And this Select button is where we put our footprints, so we're going to go ahead and press Select. And when you press Select, you'll get this giant screen. I know, it looks a little daunting at first, but you get used to it. So you can expand the little mini windows like we did earlier with our symbol libraries, right? And it just makes it a little bit easier to see stuff. And so here are all the different footprints. Now, I know it doesn't look like much, but remember, when you press this, there's still more. So there's quite a few within all these, as you can see. And so if we press on something like a capacitor and we press on this, you can see it'll give you a picture of what the footprint looks like. And this is what it'll look like when we get to our second workshop. You're going to be working with these footprints right here. So for our first resistor, we're going to find, unfortunately, there's also not a search bar for you to work with. So you kind of have to manually look through it, which can be a pain. So we're going to go here to resistor underscore THT. And then what we're looking for is R underscore axial. And you're going to see all these numbers. All these numbers are just the dimensions, as I said before. And this is stuff that you'll know because when you're designing and you're putting on the circuit board, you know the components you're going to be working with, right? And so this is where you would just go ahead and select them. So what we're looking for is 207. You're going to see R underscore axial DIN 0207. We're looking for 6.3 millimeters, 2.5 millimeters, 10.16, and then horizontal. And so this is the footprint that we want for our specific resistor. So what we're going to do is we're going to double click this, and double clicking it, you'll see that it puts it here in this text block. And so what we're going to do is we're just going to press OK. Then we have to come over here and do the same thing for our next resistor. So once again, we're going to press F, and it'll bring up that same text box. And we have two options here. So since we know that these resistors are all going to be of the same size, we can either go ahead and reselect it from here, or we can close the window. We can go back to our first resistor, and we can do Control C. Control C will copy it to your clipboard, and then we can go back to the resistor that we need to put the footprint in, do Control V, and that gives us the same exact footprint. And so it just helps to speed things along. It's a matter of preference essentially, but yeah. So next we have our diode. And so for our LED, we're going to reopen this, and we're going to go to LED. And LED would be right here, LED underscore THT. And what we're looking for here is LED 5.0 millimeters. And so we're going to double click that, and that assigns the footprint to our diode. Next, we have our capacitor. And so for our capacitor, we're looking for capacitor THT, and you'll notice all these different types of capacitors. And so we're looking for C disk. Okay, so you're gonna look for C underscore disk, and then we want the one that says 5.0, 2.5, and then 2.5. And this is the capacitor footprint that we want to be working with. So once again, we're gonna double click, and that allows us to assign the footprint to this capacitor. Here, we have to deal with our screw terminal. And so it's gonna be the same method. In essence, we're gonna look for terminal block, right? So with these different terminal blocks, you're gonna see this P, right? And what does this P mean? So this P is the pitch. And so to find the pitch, that's odd. Here it is. Okay. Here it is. So the pitch is right here. So the pitch describes the distance between your two pins, between the pins of the screw terminal. And so if we follow this vertical line up here, you'll see these two arrows and you'll see a P. And so that P is pitch. And so that's what this 5.08 is. It's a pitch of 5.08 millimeters. And that's what we want to work with. And that's what we're going to select. So if we go back to this and we press select, we're going to go to bore near 2. And we're going to do this pitch of 5.08 that we just discovered from the data sheet. So we're going to double click that. Now, the very last thing we have to deal with is the timer itself. So how do we deal with the timer? So in this instance, it was already done for us, but say we didn't have it, right? What do we do? So if we bought this component online, some websites will actually include it for you. So like Mouser.com, Mouser will provide it with for us. So it provides us with the package right here, which is PDIP8. But say we didn't know that. We didn't buy from Mouser, right? What can we do? So we can go to Google and we can type in LM555 timer. We can type in the data sheet. And if we type in the data sheet, here's one right here by TI. So if we open that up, this data sheet is very useful info. So this is the schematic of the timer, and this is the internals of the timer. If you keep scrolling, you can find what each pin does. And so this is all really useful info that you'll for sure be looking at in your various classes as they come up, as well as in the industry, if you ever decide to do anything like this. And so these are the pin layouts. Now what we're looking for is the package assigned to this timer. So if we look over here, we have PDIP8 right here. And so 8 is what we're looking for when we go to do our footprint. So if we open up KiCad again, and we go to select, we're gonna look for a package here. And we're looking for package dip right here. And so what we found from the data sheet was that it was a dip 8. So we're gonna look for dip 8, and we're gonna look for W7.62. And what you're gonna notice here is there's two types. So there's one with long pads, and then there's one that just doesn't say anything. If you look at the display, you can see that this yellow part right here gets larger. And so these are just really helpful for when you're hand soldering. And so we're just gonna go ahead and use the long pads. So with that, we assign the footprint. And so once this footprint is assigned, that's it, we're done. We're done with the schematic. So what's left? So in the PCB design process, this is where you would just do a quick check to ensure that you have everything connected that you need to. But we often happen to miss things. So that's where this tool comes in, and it's called an ERC, an electrical rules check. So what that does is it'll scan your circuit and it'll make sure things are connected the way they're supposed to be. Now, there's obviously flaws with something automated like this, right? So if I run this, you'll notice that arrows pop up where errors occur. And so something you'll notice here is that it says no connection here. And so this is KiCad's way of just warning you about all the errors that are present in your circuit. So here we would have to use a no connection flag to deal with that. But in our case, this does not matter, so we do not have to worry about that. So now that our schematic is done, we can go ahead and hit save. And we have one last thing to do. So how would you put this into the PCB editor? So to do that, you need to generate what's known as a netlist. And so if you go up to the top, there's this button right here, which looks like a red X, and it also has a text box that says net. This is the net list. So the net list essentially describes the electrical connectivity in your circuit. It just, in essence, describes how everything is connected to each other. So when we press that button, this text box will show up. We just press generate netlist, and then it'll open up a directory, and it should be located where you created your file previously. And so we can go ahead and just hit save, or you have the option of saving it wherever you want. So now that the netlist is generated and we saved our schematic, we're done here. So we can close this window. We can open back up the other KiCad window, and you'll notice that if we open up PCB, we get this screen. And this is what our second workshop will be encompassing. So just to give you guys a little sneak peek, what we can do is we can load that netlist, and normally it'll automatically have the directory chosen, but if it does not, you can press that folder icon and just navigate to where you need to. And so here it's navigated for us. So we can go ahead and press open, and you'll see all this text here, and you can just press update PCB, close, and then you'll see all these components right here. And what are these? Lo and behold, these are our components. These are the footprints that we defined and we messed with and we added, right? So this is what this is, and you're gonna notice a bunch of wires, and I know it looks daunting, but this is what we're gonna be dealing with in our next workshop, so don't worry about that. That being said, if you were here and you realized you used the wrong footprints or anything like that, all you'd have to do is you'd just have to go back to your schematic and then just change the footprint and just regenerate the net list and then just re-upload it. And so with that, that concludes our KiCad portion of this. So, and essentially the end of this workshop. So I really want to thank you all for coming out. And I would really appreciate it if you guys would fill out this feedback form. So this is our first time doing a workshop like this, and this is also my first time hosting a workshop like this. So filling out this workshop really helps me know how to improve my presenting so that it's more clear and I can fix whatever you guys are having problems with. On top of that, it also just gives us an idea of what you guys prefer, if that makes sense. And lastly, there's one last thing I'd like to do, and that is plug Comet Hack. So this workshop was done in tandem with Comet Hack, and it's IEEE's first attempt at actually holding a hardware hackathon, and it's really cool. It's a great way to improve your resume. It allows you to connect with industry leaders and your peers, because you're going to be seeing them a lot with your schooling. And finally, it's hardware based, so it's not just software based, right? I know we're in the middle of a pandemic, and so a lot of things are just being done with software, but luckily Comet Hack will also be offering reimbursements for this. So if you guys are interested in Comet Hack at all, I have this flyer on the side right here, and this has all their social media handles as well as further reasons on why you guys should attend this. But I cannot recommend enough that you guys attend this if you have the time to. And so I'm going to go ahead and just bring back this feedback form, and we will go ahead and be answering questions in the chat if you guys have any. I'd like to say thank you all so much again for attending. This has been an honor to host something like this, and I would like to continue doing this, but I'd also like to continue improving, because that's what we're all here for. We're all here to learn and to teach each other. So thank you once again, guys, and I hope you have a great rest of the night.